This is chapter 3.4 day, I'm not really sure anymore, just more log stuff. And what we're going to do is give you the last set of skills that are needed to be able to now this time solve a log equation. This is still 3.4.
This is day 4.
So what we have here is that I have a log base 6 of something equaling a log base 6 of something. Now, the sidebar on this, if I ask you to solve this, what's x? 7. Because the only way for the two numbers to be the same if the base is the same is if the exponents are the same. So what's the difference between this and logs? A log has a base and then there's a number. And if the bases of the logs are the same, that means the numbers inside them have to be the same for them to be the same. Everything about a log would have to be the same. Corresponding positions have to be the same. And so, what does that mean about log base 6 of 2x equaling log base 6 of x squared minus x plus 2? Well, that means that I can ignore the logs or say they don't matter. I want to do something like this. And just say, hey, when does 2x equal x squared minus x plus 2? Now, I hinted at earlier that the mistakes that people are making is usually on the arithmetic, the non-log side. In this case, I have 2x equals a quadratic. I should probably do what? Bring everything to one side and try to factor. So when I subtract 2x from both sides, I get 0 equals x squared minus 3x plus 2. And hopefully you're asking yourself or telling yourself, I can factor that. Are there factors of 2 that will give me a negative 3? 1 and 2. Happens to be that both will have to be negative. And if I have two factors set equal to 0, that means one or both are equal to 0. And so x would equal, and x equals 1. Now, we are now into the realm of possibilities of answers that do not work. So, I'm telling you right now to check every one of your answers. So 2 times 2 is 4. So can I get a 4 when I put it as 2 squared, which is 4, minus 2, which is 2, plus 2, 4. Hey, it works. A log base 6 of 4 will equal a log base 6 of 4. Do the same thing with 1. It should work. Now, one really easy way when I'm going to check my work is if I go and I plug in a value for x and you get a negative. Can you take a log of a negative?
No.
No. So if you ever were able to put back into the problem and get a log of any base of a negative, you automatically know that one will not work. And you're done with that one. There are several times where there will be 2 answers. One won't work. There will be a time where possibly 2 answers are supposed to be there, but yet both don't work. There's no solution. Sometimes they all work. So you have to check them. I can't stress it enough. Check, check, check. Also, we are now starting to solve these, and sometimes you have to leave a log on there. And so what you're going to have is log base 3 of 4. And you're going to switch that to a decimal. The more digits that you leave as that decimal, the more exact an answer will be, the more likely you'll get the answer that is part of the joke. Some people are getting 2.17 for an answer when the answer that we needed to have was 2.15. It was a rounding error because they used a shorter version of the approximation than they should have. So be very careful on that. Any questions on this? Seems pretty easy, right? But here's the thing, just throw a little bit of a twist in here, is what happens if, sure, this property, guys, is called the one-to-one property, that if a log of the same base is equal to each other, then the inside parts are the same. But this one has 3 different logs, or 3 log parts, but notice that they are all of the same log. What should I do on one of these sides? Well, you could technically, I guess, bring them all to one side if you really wanted to. I don't know if I'd want to. Because I want to use that ideal that a log is equal to another log.
Okay.
Because that would make my logs go away. But,
Can't you just multiply the 4 and x?
Multiply the 4 and the x. Because that's rule number 1. Rule number 1 says that if I'm adding 2 logs of the same base, I could write them together, condensing, but I have to multiply them numbers together. You remember that? So this can be log base 12 of x plus 3 equaling log base 12 of 4x. And now you have the same log equal to each other. So what happens to our numbers? Our logs cancel. So it's x plus 3 equals 4x. To solve this, again, this is where people are making mistakes. What does it mean to subtract x? It's minus 1x. And 4 minus 1 is, and then divide both sides by 3. X equals 1. And of course, you're going to do what with that answer? Check it. Make sure you check. Check, 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 check. Okay, are there questions? You guys are like, okay, this isn't too bad. But you need to remember, number 1, exponent rules. Number 2, you need to remember some log rules. And then, of course, your algebra needs to be pretty good in there, too. Last example, finishing up logs. What happens if I have a log base 5 of 2x equals 3? That is a 5. So, I have to use something else. I have to use a different inverse property. Now, question. If I said x equals 2, would it change it if I did this? Is x still equal to? Notice I could drop the equal sign down, that 3 to the x is equal to 3 squared. X is still equal to 2. What I did was I took something and made them both an exponent on the same base. There's a rule here, guys. It's this one. Log base b of b to the, nope, not that one. B to the exponent of log base b of x is equal to x. Remember that one? We talked about that one yesterday or Friday or the day before. These cancel each other out, leaving you with x. I'm going to do the same thing for this problem, but what base am I going to use? What's the base on the log? 5. So these cancel each other out, and I get 2x equals 5 to the third power. And then 5 to the third power is? 125? And then divided by 2. X equals 125 over 2. It's not too bad, right? 62.5. And again, what are you going to do? Check it. And it should work. That's got a name. It's a big E word. It's called exponentiate. Exponentiate both sides. And if you exponentiate both sides, you are basically able to, you're creating both sides as an exponent on a common base. And we do that because I want this to happen. I want these to cancel, leaving you with the number inside as the value. questions? That's it. Now, granted, there's going to be some slight modifications of this. You'll have to condense the side, using rules known 1, 2, and 3, and maybe using some exponent rules, but those are the rules. So your homework. Finish the rest of the packet. So all 8 are due. But we should be able to do, is it 9, 15, 16, which does finish up all 8. Have a fantastic day.